Hi friends, it's Kamal and you're watching Maths by Jajoria. Please don't forget to subscribe my channel. In this video, I will explain differentiating from the first principles. Now, I have explained this in my last video, and if you haven't watched, I would highly recommend you do this because I have extensively talked about this formula and everything. However, I will leave the link in the description box as well. Okay, so let's start. So the differentiating from the first principle, this formula already have been explained. How did we get that? Okay, so I'm just going to recap very quickly before moving to solving the problems. The gradient function or the derivatives of the curve y equal to fx is written as this and dy by dx. Okay, now as I said that I have explained in this my previous video, so please watch that. The gradient function can be used to find the gradient of the curve of any point of any value of the x. Okay, let's move on to the example. A point A with the coordinate 4 and 16 lies on the curve with the equation y equal to x squared. Okay, at point A, curve has a gradient g. Now show that g equal to the limit lim, which stands for h tends to 0, bracket start 8 plus h, and the bracket close. So okay, so the first we'll talk about this. Okay, by the way, when we write the derivative forms, either you can write in this way or we write this way. So we will use both of that depending on how the examiner asks. However, it's the same way of expression, same expression for the derivatives. Okay, right. So I write down this for you. G equal to, as I said, this is limit as tends to 0. Okay, so f here, you see here it says fx plus h. Okay, you see this one here, and then minus fx divided by h. Okay, so don't forget this. Let me highlight this for you. Right. Okay, so x here, you have the coordinates here. So you got here 4 plus h, okay, minus f4. Okay, so use the definition of derivative, which is the definition here. Okay, so write down here for you. Use the definition of derivative with x equal to 4. Okay, Okay, x equal to 4. So we got this one from here. Right? Okay, and then h. Okay. Now, again, limit h tends to 0. And you got here 4 plus h square minus 4 square, that is h. Now you'll ask, how did I get this one after this? So we write down here the function is fx equal to x square. Okay, says lies on the curve with the equation y equal to x square. So the function is fx equal to x square. That's why you need to square everything inside the bracket. Okay. And that's why you got this one here. Yes, clear so far? And once you have got this, then you just have to open this and solve that. Okay. So open this one. You got 16 plus 8 h plus x square minus 16 from here. Okay. Then you got h here. And here, what you can cancel this 16 and 16, but this is minus, and that's your plus. Okay, so after this, what you got here, 8h plus h square and h. All right. Now you can take h out of this and then cancel with this one. Okay, so take h and h from here, and that will give you. Okay, so you can do like this. That will cancel out that, yeah. And then it will give you 8 plus h. Okay. Now it's also asking you deduce the value of g. Right. So here we can write down. So bring this one. So this was your A. Then you got your B here. So it says as h tends to 0, yeah, the limiting value is 8. Okay, so the gradient at point A is 8. Okay, now obviously I'm in this video I'm going through the example, but as I said, if you haven't watched the last video where I really explained properly, yeah, this definition. So how I got this definition, I have extensively talked about this. Okay, right. Let's move on to another example. Okay, so in this one, we'll say prove from the first principle that the derivative of x cube is 3x squared. Okay, so let me write down here for you. So thus you have to prove. Okay, prove from first principle that the derivative of x cube is 3x squared. Okay, so from first principle means that you have to use the definition of the derivative. Derivative. So the definition of the derivative is this. Okay, so I can write down for you if you want. Definition of the derivative. Okay, so you are starting your proof with the known definition. So that is example of proof by deduction. Okay, later on you will see that we have all set the rules. We have got the like formulas for go through definition, derivatives, differentiations, and even in the integration. Okay, however, this is also the way of doing the derivative. If the examiner asks you that you prove from the first principle, then you have only this way to prove rather than other way of doing it, which we will discuss later on. So here again, fx is equal to x cube. Okay, so as I said here that we will use the definition of the derivative. Okay, now you have fx equal to x cube. Now we can say here, when I use as process C here, we can say the first derivative of the f at the point of x, or you can say f prime of x, whichever you want to say. Okay, so it's just a way of writing the derivative form. Okay, so you can say the first derivative of the f at the point x. So the first derivative here, that is your, again, limit x tends to be 0. So that is your f x plus h minus fx, and then that's divided by h. Okay, now what is that here? X cube. Yeah, okay, so then yeah, you got it, what we have to do. So limit h tends to 0, and then this one would be your x plus h cube minus, okay, so in the bracket what you have, that will be cubed. Okay, right? As I explained here as well to you, the function, a function which is that time it was square, and now is cube, so that will be the cube. Okay. Now you just have to open this one. All right, so pretty simple. I write down for you here, just in case you need to go through that. So you can I make a simplify for you rather than go write down straight away. There's a way of doing as well if you want to work out quickly. Okay. However, you can do with the XLHS cube as well. Okay, so you can do whichever way you want to do. So x squared plus 2hx plus h squared. Okay, then you can expand that, and once you expand this one, like this goes with that and all that, or just expand straight away from here, which I'm doing it, and that will give me x cubed plus 3x squared h, then 3, then you got x, then you got h squared plus h3. Okay, because I can do this way straight away, I know how to do this, so that's why I got straight away like. However, if you have a problem doing this, then there is a bit lengthy way of doing it as well. Open up this one, then solve the bracket, and you will get this. All right. And obviously I have talked about this as well in the previous video, so you can watch that. Not sure about it. Right, so move on to this. So what we got here now, maybe I can write here, limit h tends to 0, so I can change this to x cube plus 3x squared h plus 3 h squared plus h cube, and you also have here minus x cube. You have that as well, yeah, and that is divided by 4. Sorry, divided by h. I don't know where did I get that 4. Right, and you can just simplify this, please. You see you have here x3, you have here minus 1 as well, so that can cancel out. Yeah. Okay, so then what you have left with here, okay, limit h tends to 0. Okay, so here you have 3 h squared h plus 3x h squared plus h3. Okay, but that's what you have left here. Okay, so you just write exactly the same thing here. Okay, and then don't forget h as well. Right, so factorize the numerator. You can factorize that as well. Okay, pretty simple. I can say again this to you as well. Limit h tends to 0, and then we'll take h outside. So what you got here, 3x squared plus 3x h and plus h squared, and then you got h here as well. So what you got inside, 3x squared plus 3xh plus h squared. Okay, so you just got, okay, then you can just cancel this out, right? So once you cancel that, so what's left? H limit, h tends to 0, you have got 3x squared plus 3x h plus h square. Okay, now let me just write down this for you. Okay, so remember this, any terms containing h, h square or h cube, etc. will have a limiting value. Okay, so never forget this, because h always approaching 0. Okay, so h tends to 0. So what it says, limiting value of 0 as h tends to 0. Okay, once you know this, then you know I can write down here as h tends to 0, your 3xh is tends to 0 and h square is tends to 0. So first derivative, okay, so that would be 3x squared plus, if that tends to 0, that tends to 0, you only have got this 3x squared. Okay, so therefore the derivative of x cube, as asked here, prove from the first principle that the derivative of x cube is 3x squared. And that's what we got here. So the derivative of x cube is 3x squared. Okay. Hope it's clear to you. Okay, let's do other questions as well, other exercise. Something you can get in your exam as well. Okay, it can carry a good marks as well. So let's see what we can do. So I have got here one of the example where okay, so let me write down first here. Okay, so the point A with coordinate, so I'm just going to write down here first. The point A with coordinates -1 and 4. Okay, so don't forget that. -1, sorry, that's -1 and 4. Okay, lies on the curve with the equation. Okay, so lies on the curve with equation. So this time your equation is yx equal to x cube minus 5x. Okay, then the point B also lies on the curve, has a coordinate. So this is your A, then you also have the point B. Okay, so that is also lies on the curve and has a x coordinate, and that is -1 and plus h. Okay, so this is what has been given to you, right? Now what is asking for is show that the gradient of the line segment AB is given by, so let me write down that. So it's asking you that you need to show that gradient the line, obviously when you, if you have a point A and B, and if this has any curve and you make this point, so you're just asking that that gradient, show that the gradient of the line segment AB, okay, is given by h square minus 3h minus 2. Okay, so first you need to show that. Okay, so show that. Right, how will you do this one now? Okay, so as you know that your let's say it's -1 and the 4. Okay, right, you got your curve, the equation. So the curve equation is this. Okay, curve equation is this. Okay, curve with equation this, and then you got your A coordinate and you got your B coordinate as well. Remember that as well. -1, and that is your plus h. Okay, -1 plus h. Okay, sorry, there's no comma here. -1 plus h. Okay, yeah, sorry, there's no comma. It says the point B also lies on the curve and has x coordinate. Okay, so that is your x coordinate. So it's not the B coordinate, it's only the x. Okay, let me write down this here, not to get confused with. So the point B also lies on the curve and has x coordinate. Okay, so it's x coordinate, only x coordinate. So the x coordinate, only the x coordinate, which is -1 plus h. Okay, so don't get confused with that. Then it's asking to show the gradient of the segment AB is given by h square minus 3h minus 2. Right? Okay. Let's sort out this then. So y, so let's sort out this. Y coordinate of okay, point B, because that's what we don't know. We need to find out that. Once we know the coordinate A and B, then you know what to do. Okay, then we go straight to our first principle. Okay, definition of derivative, and solve that. All right, let's do this one then. So the y coordinate of the point B, so that can be written as So you have your x, which is -1 plus h, that's cube. Okay, that will be from here. Okay, so x already been given to you. Y we need to find out. Yeah, from this equation. So you insert the value of your x in there, and you got your 5 -1 plus h. Okay, it's clear so far? Okay, that's from here. Okay, so that's your equation. Now, if I ask you what will be the gradient of AB. Now, if I ask you that, so you can say, now what I'm using here, so you got here -1 plus h, that is your cube, okay, minus 5 -1 plus h, then minus 4. Okay. Now you will say, how I got this one? So I'm gonna go and just use the gradient of any line. Okay, gradient of AB here, and that is you probably remember was y2 minus y1. Yeah, I have discussed that as well. x2 minus x1. Okay, so this is what I'm exactly doing this one here to find out. Right. So using this, you can say getting the gradient of AB. The y2 here, you got this here minus y1, sorry, and that is your 4 minus 4, sorry. Okay, then you got here x2 minus x1. Okay, so -1 plus h. Okay, and you got minus, yeah, and what is your x1 here? That is your -1 already. Okay, a coordinate 1 already been given to you, because everything here is a coordinate 1 is your x1 and your y1. Okay, so this is your x1 and y1, and that's what we're inserting here, -1. Okay, I hope it's clear so far. Right, now let's open this. -1 plus 3h minus 3h square plus h cube. Okay, so I already have done this one, -1 with the cube, so that will give us this. Then 3h, so the cube bit of the -1 I haven't really mentioned in this one, that will just confuse you. So rather I have written the next step, which will give us this. Okay, right, then you got, so this one we got this, and let's open up this now. So that's minus and plus, that's +5 and -5h and -4. Okay, in here this minus and minus, that's plus, and that's minus here, so that will cancel out this. Okay, once you open that, so that will be cancelled. You have what you have got now, only h. Okay, clear? Then let's solve this. Okay, and that is your h cube minus 3h square minus 2h, and that divides by h. Okay, so how we got this one here? So let's go here and see what we have cancel out here. All right, so you see here, you got here minus 5h, and then you got here 3h, and so that gave us minus 2h. Okay, you had h3 here already, so you got this one from here, minus 3h square, you got it from here, you got this one from here, then you got here minus 4 and minus 1, that is minus 5, and you got plus 5 here, so that all will go. Okay, and that will give us this. Once you have this, then we can factorize the numerator, and that can give us take our h outside. Okay, that give us h square minus 3h minus 2, and then h here, cancel this out, and that will give us h square minus 3h minus 2. Okay, now what else has been asked here? So that was your a, so we got this one here exactly the same, h square minus 3. So it's a gradient of the line segment AB is given by this, so this is what exactly we have achieved that. We have achieved that. Okay, yeah, got that. Now there's something else will they ask for, and that was the deduce the gradient of the curve at point A. Okay, so let's deduce the gradient of the curve at point A, right? Okay, so I think you got it what I'm going to say here. So let me write down here for you exactly the same way I have written previously. So at the point A, okay, as h tends to 0, yeah, h square minus 3h minus 2, h tends to 0, that will 0, that will 0. Okay, so what we have got here, minus 2 only. Okay, so the gradient is equal to minus 2. Okay, so this is what I will get, this is what you will get. Okay, so I hope you understand this. You definitely get one kind of exam question where you have to use first principle. Okay, so definition of derivative or something similar type of question, which is this. So you might have this where you have to use this form. Okay, like this has been discussed. Okay, it's just a gradient of any line, and that can be found with this formula. And also we have used here definition of the derivation as well, and can use that as well. Now when you move on to the next bit, we will talk about differentiating. Okay, and in that we will have some formulas as well, discuss what we have, because not everything can be solved in this way. because that will be really lengthy. So when I say solve in this way, which means that cannot be used the definition of a derivative all the time like this, because that will be really lengthy. So, and the differentiation or the calculus can be really complex as well. And so not to make too complex, we will come to the formulas and different types of formulas where we can use that formulas in to differentiate. Okay, so that will I discuss in my next video. So keep watching, right? And I hope that you find this video very informative. So please like and subscribe this video, and be sure click the like button and drop a comment if you have any question. Okay, so anything is not clear to you, ask me. I'll do my best to reply. Okay, for this time, thank you.